Good morning, everyone. We're starting off our lesson with jokes. Mrs Warburton jokes again. Right, are you ready? Right, so you know the relevance of the jokes. What topic are we doing at the minute? Shape. That's right, we're doing shape. So we've got shape jokes to start us off. Are you ready? What did the triangle say to the circle? I don't know. What did the triangle say to the circle? You're pointless. Boom. Next one. Why doesn't anyone talk to circles? Why doesn't anyone talk to circles? I don't know. Why doesn't anybody talk to circles? Because there's no point. There we go. Let's see if there's any more. Are there any more? Are there any more? Do you know some shape jokes? If you've got a good shape joke, send it in to me so I can read it and maybe I'll read them out next week. What a great way to start our shape topic. Right. That's cheered me up. We better begin the lesson, hey? Let me try and share the screen, see where we're at. Now, yesterday we were what day is it today? Thursday. Yesterday you were making 3D shapes for non-screen day, weren't you? How did you get on? Did you decorate them nicely as well? Because they were blank ones, weren't they? So I thought you could get creative. I hope you enjoyed it. I hope it was a nice relief from staring at screens every day. However, welcome back. Welcome back. So it's Thursday. So not yesterday, the day before, when you were still staring at a screen, we were counting, and we had our counting eyes on, and we were counting sides. Well, today, you're not counting sides, you're counting. Oh, hang on. Vertices from beginning, please. Here we go. Count the vertices on 2D shapes. That's what we're learning about today. Meow. Count vertices on 2D shapes. What's the vertices? I hear you shout. More will become clear in a minute. Get ready. Warm-up question. Which one of these 4 shapes is the odd one out? Pause me now to see if you can work out which one it is. Ooh. Welcome back. Which one did you choose? Did you come up with a good reason as to which one you chose? Maybe you chose the sphere. If you did, well done. The sphere is the only one that can roll. The ball can roll. Well done. Did you choose the cylinder? The cylinder is the only shape there that, if you were to cut it in half, has identical circle faces still. They don't change. Look, if you cut through the cylinder, it still has an identical circular face on the other part. So that's why that one is the odd one out. Pyramid. Did some of you find a reason as to why the pyramid is the odd one out? Well, that's the only one that can't roll around, isn't it? I'm sure there's other reasons as well, but unlike the ball and the cylinder and the cone, you cannot roll a pyramid. It doesn't work. Cone. Did anybody out there think the cone was the odd one out? The cone is the only shape there that only has one circular piece. So now I know. Let's move on. Let's learn. Here we go. We're familiar with this picture, aren't we? We looked at this yesterday, and we had 2 children, Dexter and Annie, are our 2 children here, and they were looking at this triangle, and Dexter said, this shape has 3 vertices, and he was absolutely spot on. Can you see where the vertices are here? It's the corner points. 1, 2, 3. And little Annie said, no, this shape has 3 sides. And also she was absolutely spot on and correct, because look, there's 1, 2, 3 sides there as well. So both children were right with their opinions. So now they're thinking of some more shapes, and Dexter, he says, my shape has 5 vertices, and Annie's joining in the game and she's saying, and 5 sides. So they've both thought of a shape, and it's going to have 5 vertices and 5 sides. Let's see what shape they're thinking of. 1, 2, 3, 4. There's our 5 sides, children. Can you see? Let's see if it has 5 vertices. 1, 2, 3, 4, 5. Can you see them? What shape is it that they were thinking of? That's right, a pentagon. Their pentagon has 5 vertices and 5 shapes. 5 sides. Now they're saying that my shape has 4 vertices. Okay. And it's got 5 sides. Let's look at the shape that they're thinking of to see if they're right, hey? 1, 2, 3, 4. There's the 5 sides, children. Can you see it? And Dexter says it has 4 vertices. Oh, hang on a minute, Dexter. You've missed one out. I can see there's 1, 2, 3, 4, but can you see, children? Look, there's another vertices there as well. Let's change his answer round. That's better. The shape has 5 vertices, doesn't it, everybody? And it has 5 sides. Dexter says, when working with 2D shapes, are the number of sides and vertices always equal? And Annie's just not sure. What do you think at home? When working with 2D shapes, are the number of the sides and vertices always equal? Have a think for a minute and see if you think they are or they're not. Welcome back. Hopefully somebody didn't see you. Right. Oh, it's all right, you wouldn't have seen it. Right. Here we go. Let's see if it's right. Now, starting at the top, it says a triangle has 3 sides and something vertices. A square has 4 sides. A rectangle has 4 sides. A pentagon has 5 sides. A hexagon has 6 sides. We know that. So do they have the same amount of vertices? Let's have a look. A triangle here. Can you see it has 3 vertices and 3 sides? A square, can you see the 4 vertices? 1, 2, 3, 4, and 4 sides. A rectangle has 1, 2, 3, 4 vertices and 4 sides. A pentagon, 1, 2, 3, 4, 5 vertices and 5 sides. And a hexagon, here's a hexagon, children. 1, 2, 3, 4, 5, 6. So it could well be true that when we're looking at 2D shapes, there are the same number of sides as vertices. Dexter says, my shape has 5 vertices. But Annie says, but it has 10 sides. So they think that this shape breaks that mold of what we just spoke about. My shape has 5 vertices but 10 sides. Are they right? Have a think. Let's count the vertices. 1, 2, 3, 4, 5. That's not all the vertices though, is it, children? Look, there's some more. 6, 7, 8, 9, 10. So there are 10 vertices and 10 sides on this star. There you go, Dexter, you change your answer. My shape has 10 vertices and it has 10 sides, so that too is keeping with that pattern. Have a look at your worksheet, children, and have a go at all the questions on there. If we look at it quickly together, you will see it looks like this. Does it look like that? No, it looks like this one. Here we go. Counting the vertices on 2D shapes. So you need to, for question 1, it's quite straightforward. You're counting the vertices and you need to write in the correct number to finish the sentence. On C and D, you need to write the name of that 2D shape in there as well. For question 2, you need to tick the shape that has 4 vertices, and there's a little white box by each shape for you to tick if it has 4 vertices. And for question 3, oh crikey. Hi children, sorry, that was Mrs Walton calling me. That was nice to have a chat with her. Right, there we go. Anyway, carrying on, let me share the screen again. Hopefully my phone won't go off. I'll put it on silent now, so if she calls back, she'll have to wait. Oh, hang on a minute, what am I doing? Share screen. We were talking about your worksheet, weren't we? Are we back up here? Yes. So on question 3, you're ticking the shapes with 6 vertices. So count them carefully. There's a whole array of shapes to look at there. And then on the last page, you need to count all the vertices in these 6 shapes and write the total in the box by the side. And then you have a word problem and some reasoning for the last part of question 5 and 6. So here, Ron, on question 5, Ron is saying, my shape, oh my goodness, my shape has more vertices than a triangle, but fewer than a hexagon. What shape could Ron have? So I want you to have a think carefully about that. It says compare answers with a partner. Maybe you could ask a sibling the same question, your brother or your sister, to see if they come up with the same answer, or a grown-up, and see if you have the same answer as them. Maybe there's more than one option you could go for. And question 6, Rosie is making a pattern out of shapes. How many vertices are in each term of her pattern? So there is a if you see where my mouse is, that's the first term, that's the second term, and that's the third term. And can you see each time the pattern goes, it's extended. So I imagine the number will get larger. Oh, I've just given you the answer to question B. Anyway, I want you to explain it in more detail. And create your own pattern to finish off. So plenty to be getting on with there, children. Hello, plenty to be getting on there with. Enjoy it. Have fun with your shapes, and I'll see you tomorrow for some Friday maths fun. Shall I have a quick cheeky sneak preview as to what we're doing tomorrow? Ooh, oh, drawing, children. That'll be a good lesson. Okay, I'm excited to see you tomorrow for our shape lesson, our drawing shape lesson, drawing 2D shapes. So I'll see you then. Work hard, everybody. Let us know if you need any help at all, or if you want some extra work, contact us on Seesaw. Bye. Take care. Be good.